All right. Well, we're a minute into our hour-long webinar, so we should probably get started. I want to start off by welcoming all of our attendees to this webinar. Thank you for joining us for our discussion on innovative line technologies in transforming sanitary sewer systems. My name is Brandon Tremelling. I'm one of our presenters today. I'm the technical resource engineer for Geneva Pipe and Precast. If you have any questions, please post them in the chat or the Q&A. For part of the presentation, I will be presenting, and for another portion, my co-presenter will be presenting. And during that portion, either of us will be answering that, and most likely we will be saving some of those to a question portion at the end. But without further ado, I'd like to introduce my co-presenter, Elena Mikhailova. Elena, would you like to introduce yourself?
Yeah, absolutely. Welcome, everybody. I'm so happy to have you today with us here to learn about the products that you may have never heard of before, and something that might be very useful for your next project. My name is Elena Mikhailova, and I'm a product manager for Line Products. With that, I guess we can go ahead and get started.
Absolutely. All right, so to get started, I just wanted to take a moment to mention a little bit about Geneva Pipe and Precast. We are a precaster that recently was acquired by Northwest Pipe. So we've been around for nearly 70 years in the industry, providing various precast concrete solutions as well as innovative technologies to accompany some of that precast infrastructure. We are part of a much larger company that is spread across the United States, and so that provides for interesting opportunities for us to collaborate with other engineers and agencies from around our country that may have unique challenges that normally we don't deal with. So it really provides interesting opportunities for additional growth and innovation. Today, we want to talk specifically about innovation in the area of concrete corrosion. And the portion of the presentation that I'm going to be covering is specific to the science of concrete corrosion, the H2S or hydrogen sulfide corrosion that will eat away at concrete. We'll talk a little bit about the impact of this problem in our industry, as well as approaches that have been more historical in nature for preventing and possibly rehabilitating this structures that have been affected or may be affected by this problem. At that point, I will hand the presentation off to Elena, who will talk about some of these innovative advancements for both new installation as well as the rehabilitation of existing infrastructure. And with that, I am going to jump right into it. So microbiologically influenced concrete corrosion is first and foremost a mouthful, I like to say. So we generally condense it down to the acronym MIC, which we'll primarily be referring to it as from here on out. But it is the leading cause of deterioration in concrete sewer systems. It's not necessarily indicative of poor design or anything that's wrong with the wastewater makeup itself, but it is a natural process, and as a natural process, it needs to be planned for, inspected for, and sometimes we do things to try to, address this problem, but on the surface level, as in that photo to the right, you can see higher up on the wall, it looks like the method that had been used to protect this concrete structure looked fine on the surface, but until you peel it back and look underneath, sometimes we get the situation where a Band-Aid solution may not be the right approach. So it can sometimes go undetected, which leads to greater problems. Now, the actual chemical process that takes place is what happens is the microbes that are inherent to the wastewater, they accumulate in the biofilm that's under the water line. Now, in that biofilm, they have all the time in the world to break down the organic carbon that's native to the wastewater and produce acids. Those acids, through various factors, can become airborne. And once airborne, they react with oxygen and moisture to eat away at concrete, the components of that concrete structure. That process eats away the concrete layer by layer. And so in this photo you see here, you can see almost little sheets of concrete in that deteriorated pipe. And that is showing how layer by layer we can eat away at the wall thickness of our structures, eventually exposing the reinforcing steel and possibly leading to collapse of the structure, which can lead to all sorts of problems, including health concerns, safety, and so on and so forth. So like I mentioned, there are various factors that can cause these acids in the wastewater to go airborne and then attack the concrete. The first and foremost of those factors is heat. The hotter it is, and when I talk about heat, I'm not talking about drastic changes in temperature fluctuations. I'm talking about slight increases that just bridge that gap to the energy of activation or the required energy for these chemical reactions to take place. And so if we have slightly warmer wastewater, we're more likely to see those acids go airborne. The next one is turbulence. If we're aerating the water, that's going to cause those acids to get swept up into that aeration and then enter the atmosphere. The longer the transit times, this one's a little bit tricky because often this one's out of our control, but the longer the transit time, the longer those microbes have to build up the concentrations of the acids in the wastewater and then also the air in the pipe as well. Wastewater makeup is an interesting one. It can be anything as unique as you have specific industrial effluent mixing with residential or more municipal wastewater that's causing a problem, or you have contamination in your soils, which is leading to contamination in your groundwater, various things. This was an interesting map I found in preparation for this presentation that showed all the different groundwater contamination sites throughout Texas. And so depending on where you specifically are designing a project, this may or may not be a problem, but this is just kind of a catch-all term for whatever unique features are impacting, a specific agency's system that oftentimes are unaccounted for. And finally, the last one is water pH. Now this one may seem simple or basic, but the lower the pH or the more acidic the pH of the water, if we're introducing more acids, the more likely they are to go airborne. So there's all these different factors that we deal with that definitely impact how big of a corrosion potential a system has in for different reasons. Now that we've kind of covered a little bit of the science, I want to now spend some time talking about actual disasters and case studies that demonstrate the impact of this problem. The first one that I want to talk about is one that is a relatively large disaster as far as sanitary sewer overflows go, and that is the Jackson, Mississippi disaster, where a lift station collapsed or a pump station failed after a concrete pipe collapsed due to corrosion. The overall volume of wastewater that spilled was 19.7 million gallons, which is only what was measured. It wasn't the total volume. It was just what they could account for when they found that the wastewater was flowing directly into the Pearl River that runs through Jackson, Mississippi. Now, this was a problem that had been years in the making, as demonstrated by the table on this slide. This was a table that I found of all the different SSOs or sanitary sewer overflows for the Jackson, Mississippi area over time. And even though this one that we're covering is pretty significant, you can see here that there are others of nearly 7.5 million gallons, 1.9, 1, 2.7, and so on and so forth. But the interesting thing about this table is if you look at the dates on all of these SSOs, if you look closely, you can see that these were all within a period of a few months, meaning that these problems were happening over and over and over again. Further in my research of this specific case study, I found this quote, which says that in 2020, more than 520 million gallons of SSOs occurred. And I don't know if you call this progress, but 2 years later, they'd really cut that down to only 216 million gallons, which is by any measure an environmental disaster. Now, what had taken place was because Jackson, Mississippi was being more reactive than proactive in the work that they were doing to maintain their system, they quickly got to the portion of care that they realized they could not keep up with the disasters as they were taking place and very quickly ran out of money. When I say that, there was a study that came out several years ago by FEMA that showed that for every $1 of proactive care spent, it's equivalent to $6 of reactive care. So in cases like Jackson, Mississippi, where there were all these disasters taking place and the great increase of cost it was to deal with those disasters, the city ran out of money and lost the ability to maintain their own system. More locally and on a more small scale, which might be more relevant to, engineers in more rural areas, this was a photo that I took myself at the headworks of a local wastewater treatment plant. I took this photo right after I gave a presentation, much like this one, and found that, well, as discussing this problem, I turned to this group of operators and I said, so how many of you seen MIC in your system before? And this was a group of seasoned operators, and all of them looked at each other and looked at me and said, we haven't. And I said, really? How much of your system is concrete pipe? And I'm not just talking about manholes, I'm talking unlined concrete pipe. And they said about 80%. And it wasn't until one guy at the back said, maybe I've seen something like that. And we walked right outside to the nearest manhole because it was at the treatment plant, popped open the lid, and saw what you see here. And just to be clear, for those of you that aren't super familiar with concrete infrastructure, concrete's not meant to curl away from the walls like that. That definitely is a significant case of corrosion. And this was just an example that I like to highlight because if you're not looking for this problem, it's easy to miss. And in this case, these operators, even though dealing with concrete infrastructure in their system for decades, hadn't realized that this was impacting the resiliency and sustainability of their infrastructure. So mentioning costs and these studies by FEMA, my company, we put together kind of a research study some time ago where we analyzed different methods to treat this problem, either through prevention or protection or things like that. And I've left the units off of this, but I just want to invite you all to think about for a moment what it means, when we use the phrase life cycle cost. If we're putting in a system or a component of a system that we're expecting to last for the lifespan of, the infrastructure that it is connected to, oftentimes we look at infrastructure in maybe 100-year lifespan. For concrete, we generally look at a 100-year lifespan. And so if we're going to be putting in a structure that has the possibility of experiencing corrosion and degradation, then whatever we're doing to prevent it from corroding and deteriorating should probably also last 100 years. Now, in trying to quantify some of these things, my company, looking for some of these solutions, we decided that we wanted to identify how big of an impact this is to the US market, for example. And so just as a quick question, and this is more rhetorical, but just think to yourselves, how much would you guess the US spends annually on the rehabilitation and replacement of concrete sewer pipes? Now, as you kind of think about that, think the scale of that, even $4 billion is a pretty enormous number. And to answer this question, we did what any modern scientist, research engineer would do. And of course, we turned to Google and found research studies from all over the world, from Canada, from Germany, from China, and we're rather surprised to find that here in the United States, it is a $14 billion industry dealing with the rehabilitation and replacement of deteriorated sewer pipes. So a massive problem that we decided that we wanted to try to be a part of to address this and provide solutions for our industry and for our local markets. So looking specifically at this research study that we were working on, we identified that there are a few standard approaches to treating this problem. Probably first and foremost is those field applied coatings. Also, polymer concrete has seen a kind of more recent rise. And finally, lined concrete, which Elena will cover more in depth. But I want to introduce this kind of concept now where we talk about life cycle costs. And if we're trying to put a component of our system in, are we making those decisions on what is going to make the most sense for the lifespan of the structure? Because at Geneva Pipe and Precast, our goal is that if you are going to be putting in a new piece of infrastructure that is going to address a problem, or you're trying to rehabilitate a structure that has had a problem, you should ever only have to do that once. So, looking at corrosion, how do we identify if we're seeing corrosion in a system? Now, there's a few kind of telltale signs. Going back to this photo that I took, if you see white or black discoloration, white is actually the formation of gypsum, which is the byproduct of the concrete corrosion. Black is the accumulation of sulfates. So in this photo, you can see some white areas, some black areas. If you also see yellow, that can also indicate some sulfurous compounds. The smell of rotten eggs indicates septic conditions that, really cause little microbes to thrive. Finally, if you're seeing flaking or pebbly or curling textures, if you see kind of a rough concrete surface, that's not necessarily a problem. But if you're seeing some of the aggregate or gravel exposed, that indicates that there has been some degradation of the concrete and that wall thickness is starting to get eaten away. So that also can be an indicator. Finally, and I'm hoping that this comes through well for you, but here's a video that I also took of a rather severely deteriorated manhole where truly just with the brush of a hand, this concrete is just falling away. So it can get to some pretty severe conditions. Now, as I mentioned, we've got some prevention and rehabilitation methods that I'm just going to touch on. I'm only going to talk about the first few, but generally we've got chemical additives, field coatings, and alternative materials that don't react with the corrosion. And then we'll talk about line structures and structural rehabilitation, and that's where I'll hand it off to Elena. So the first is chemical additives, and this can be either more of like a concrete admixture or something that is sprayed on top of the walls as a very temporary measure. As a concrete precaster, I can tell you there's a reason why we don't use concrete admixtures specifically for concrete corrosion. And the reason for that is because essentially the reaction is like an acid and base reaction. So like your elementary school volcano science project, where if we are adding more bases to the concrete, then there's more for the acid to attack that isn't the concrete. But eventually, given enough time, those bases will get eaten away and the concrete's going to be targeted. And so generally we try to stay away from chemical additives because they don't hold up to significant corrosive potential. The field applied coatings is an interesting one, very popular, can be potentially cheaper initially. There's many options to choose from. It's pretty dynamic. A specific agency can choose what they want and say, we want this thickness and this type and this application, things like that. So that's good. But generally, it has a lower lifespan, requires ideal conditions for success. And as you can see in this lovely Jackson Pollock painting here, oftentimes it doesn't do too much to protect the concrete underneath if there's even a pinpoint access point for those acidic components to get in and behind it. Now, this is actually a best case scenario because it's clear that there was corrosion going on behind this field applied coating. But in some instances, we can have this situation where, as I demonstrated earlier, you can see higher up on the wall, it looks like everything's fine, but behind it actually is a much more severe corrosion problem. Finally, alternative materials and inserts. This is an option for essentially removing the cement from the concrete and introducing an additional material. In this case, we're talking more about polymer concrete, which is non-reactive to the corrosive elements. Generally, it performs pretty well, but for rehab isn't a total structural solution and also can be a little bit more expensive. And with that, I think I'm ready to hand things off to Elena, if you are ready. And I'll be back for Q&A at the end.
Brandon, thank you for the great introduction. So this is a picture of our facility where we started manufacturing corrosion-resistant solutions. We had this facility for a long time. Geneva Pipe has existed for a long time, but corrosion-resistant solutions came along in 2019, 2020. We purchased we purchased technology and equipment, so we're now able to offer corrosion-resistant solutions here in US throughout the country. Not where our facility is located in Utah, but we also have capability of making products in our other parts of the country. So we offer lined concrete, so which is not a new solution. However, our product has a few more innovative solutions as compared to traditionally lined concrete. You may be all familiar with T-lock liners that have been used since 80s. It's a very popular solution for protecting concrete, specifically in California. I know some Texas market have PVC line concrete also specified in the specifications for various agencies. So basically, there was a PVC liner. It has on the right top picture, you can see that what kind of anchoring system it has. It has a parallel running ribs that when concrete is poured in the form, it embeds into concrete. So that creates a locking system. So with that product, you could line cast in place structures. You've got to support them. You could line manholes, pipes. So that is the idea behind lining. So T-lock had one issue because it had parallel locking anchors. The water could get trapped behind the liner and create the bubbles. And something to keep in mind, and engineers don't necessarily always think about it, like when you have high water groundwater, so the water gets trapped behind the liner and the liner may fail. This is one of the major mechanisms how the epoxy or spray-on liner fails. Typically, spray-on liner, it's attached to the concrete through chemical adhesion, and it's not reinforced, it's not mechanically embedded. So when the water gets behind the liner, in most situations, you're gonna get the water behind the liner. So it starts cracking, and because it's brittle, it starts cracking, and you gradually gonna have a failure behind the liner. Once you have cracks, your gases will penetrate in between the liner and concrete, and your concrete start deteriorating. So it's very important to have something either inert that does not react with H2S gases, or you've got to have mechanical embedment for lasting solution. So we offer HDPE lined concrete. So traditionally, HDPE liners, you weld the tubes, you cast them into pipes or manholes, and then once, so this is the anchoring system is slightly different than T-lock, as you can see. The agro liner way has V-shaped anchors. So the independent anchors, they're going to be embedded into concrete. So if one anchor, let's say, fails for some reason due to water pressure, you have other 100 anchors holding that liner, so it's not going to peel off. With T-lock liner, it was a little bit different situation because you had parallel running anchors, and if the water gets behind the liner, it could tear the whole liner out because they are dependent on each other. So traditionally welded line RCPs or structures, once you cast them, install them, somebody will have to come in and weld the joints in between the joints, because you want to have that continuous lining in between the joints. So a welder of a right size goes inside the pipe and welds the joints around the pipe. It doesn't stop there. So once it's welded, and it's very, I guess, labor-intensive process. And for smaller pipes, it gets even harder for the person to fit into the pipe. So once it gets welded, you've got to have some sort of testing to make sure you have thorough penetrated weld to make sure you don't have any pinholes so the gases do not go in. And this was one of the weak points in T-lock. There was no way except for the vacuum testing to tell whether you had a weld without the without a defect. So sometimes agencies now go in, and once they pull the liner in the failure points, they see that there is a corrosion behind the liner. So with the yellow liner, agro liner, now there's a welding strip. They have metal backing, so you have an option besides doing the vacuum testing on the joint. You can actually do spark testing to make sure you don't have any penetrations. So our pipe is removes all the risks of bad weld and speeds up installation because you don't need to weld this type of product. So our product is perfect pipe. So it's a traditional lines RCP with HDPE liner with those V-shaped anchors. They embed it into concrete. Once you install these pipes, the beauty of it, you don't need to weld it. So it has on the bottom left, you see there is a black coupler. Once you install the pipes, you can connect them just like a regular RCP that you see for storm. The anatomy of the pipe is on this slide. So you have the RCP. It can be made in different classes that you used to see in class 3 through class 5, depending on your loading conditions, or it can be special design if you need a special loading like construction or aircraft, it can be done. And so we installed this black coupler that's made out of corrosion-resistant material, and it has double tilting edge gaskets. There are 2 of them that's sitting on this black coupler, and we insert that coupler into the pipe, and it's delivered to the job site, so the contractor doesn't have to mess with putting the gaskets on, equalizing it. So the process of installation goes really fast. So you get the strength of the RCP, but you also get corrosion-resistant solution, and you don't need to weld it. So you kind of speeding up the installation and reducing the risk of bad weld. And of course, that way the agencies can save money. Just for as an example, traditionally line RCP, they wouldn't have that connector, the black connector, so they would have to cut the pipe and then stick it into the manhole, and they do all kind of complex welding. So for that, you're hoping that your welder is really good and certified, so you don't have any defects in the weld. Obviously, this particular picture has really good welds, looks like it. And as far as connecting to the manhole, your pipe, this perfect pipe can be connected to any manhole, any new manhole. So we can make the FRP bell insert that whoever makes the manhole, they can embed it or cast into the structure. And then once you have this bell connector, you will have this perfect pipe coupler that you will insert into it, and so that your pipe will smoothly connect to the manhole. And if you're curious about whether you can connect laterals to perfect pipe, yes, you can. It can be either we can pre-core and install the connectors at our facility, and it will be delivered to the job site with the penetrations. But as you know, that never happens, right? You're planning a hole on one side in one place, and then once you get to the job site, it's going to be 100 feet away. So coring in the field is another option. So we have the special connectors where you can core it and install it, no welding required. And this is how it looks from the inside on the left and from the outside on the right. This is a picture from our very first project, which we're very proud of in Utah with a perfect pipe installation. We had 24-inch and 30-inch pipes installed, about 2,400 linear feet. Total, the agency chose us because of the strength of the pipe they needed to go under the future highway. So they didn't want to think about, compaction of the soil. So they wanted to rely on the strength of the pipe. That's why they chose perfect line pipe. So besides perfect pipe, we offer entire solution to have fully corrosion resistant system, not just a pipe, but also line manholes. So you can have fully corrosion proof system. So one thing I wanted to mention about perfect pipe, they come in the 10 feet lengths and available sizes 24 through 60. And if you have a pipe above 60, you still have to traditional weld it in the field. And why did we pick the smaller sizes, and why are the smaller sizes only available? Well, because those are the sizes where human entry and working inside the pipe is more complex. Imagine going into 36 or 24-inch pipe and trying to weld the joints. So with perfect pipe, you don't need to worry about it. You just install it. All the work is from the outside of the pipe. And that's a reason the perfect pipe would be superior over the traditionally lined HDP line pipes. We don't have to weld the joints. And for the manholes, again, we offer manholes that are fully lined from the base all the way to the lids. They don't need welding either, just like our perfect pipe that speeds up the installation for the contractor and removes the risk of having to weld the joints in the field. And I will talk about these products in the next slides. So this is a picture of from one of our projects that we did also in Utah. You can see that on the picture on the left, it's a lined base. It's lined with FRP, or fiber reinforced plastic. It has 4 penetrations, the main trough, and you have 2 inlets. That just tells you that we can make any configuration you can imagine. If you have 6 pipes coming in, as long as it meets the design, we can line that base for you. And then the top portion, the riser, is a little bit lighter liner. It's because it's lined with HDPE. You may be wondering why is the bottom lined with FRP and the top is lined with HDPE. Is because the bottom, the base, is a complex shape. You can't just cut it up and start lining the channels and then you have to weld it, so that again you don't want to have those joints or those welds. So we line it as a one piece, so you don't have any penetration points or any seams that you can have the gases go through. So the complex shapes lined with FRP and simple circular shapes lined with HDPE liner. And on top of it, our line manholes feature gaskets that overlap the spigot. So you may have traditionally seen that, you've seen probably manholes with gasket, but typical gaskets in a traditional manhole sit on the outside of the spigot, so they don't really seal the top of the spigot. So with our gasket, it's SDV seal gaskets. They go all the way to almost inside of the manhole. So when you stack the section, they're gonna fully seal and make the joint watertight from the inside out. We can also line the cones. So first we manufacture the cones and cast it into the cone form. So you can have either line cone or line flat lid, depending on what you use. And a little bit about the FRP material. So there has been testing done where FRP lined manholes were installed, and then one of the manholes was dug up, and Some of the samples were taken from that manhole. After 20 years in service, they measured the thickness of the liner. You can see over here, they took several core samples, measured the thickness of the liner, looked at the concrete under the microscope, and they found there was no deterioration. There's no significant reduction in the thickness of the liner itself and no damage to concrete. That shows you that this material is not just abrasion resistant, but also protects concrete really well. And this is a picture of the gasket that I was telling you about. The yellow part is your liner anchored in, and then you have a gasket goes all around. So it seals on the top part of the spigot and all the way in the annular space in the joints. So it kind of provides you a seal from the top and on the side as well. So the gases cannot go in between the liner and concrete, which is a great feature that you don't see a lot of. And we do offer a 50-year warranty. If you think about epoxy spray and liners, typically don't get a lot of warranty because the life cycle is not that long, but we are so confident in our product that we do offer 50-year warranty, and these concrete manholes are 100-year design life. If you're wondering if your agency for any reason uses steps, it's possible we can make them. We do not recommend making steps. Now we see more and more agencies walking away from the steps, and they're just lowering maintenance people through the tripod, which is a safer solution. First of all, you don't know the condition of the steps unless they're corrosion resistant. And plus, when you install the steps, you introducing additional penetration points where you have to weld around every single penetration that creates additional possibility for the pinholes and possibly the gases getting in. Also wanted to talk a little bit about connections of the pipes into perfect line manhole. You can have an option of using the boot. This is a traditional way. Not every agency likes that. We see more and more once they learn about our option, that what we offer, they walk away from the boot because they think our option is better option. So you've traditionally seen boots used when you connect to the structure. We would line the opening in the manhole, and then you insert the boot into line opening, so you don't have any points of gases getting in. One of the problems with this is on the outlets, when the effluent is going through, it can get in between that pipe and that annular space of the boot, which can create additional odors and effluent standing there. And so some agencies just grout the space, and then it becomes like a maintenance item because eventually the grout going to be eaten out and you will have to regrout it again. So our option is to use rigid connectors. You can see on the left-hand side, they're made out of polypropylene, which is a corrosion-resistant material. Each one of them has gaskets. So as you can see, they color-coded. Each color represents the type of the pipe that goes into the manhole. So not only the watertight joints with gaskets, but also just looking, if you've been using them for a while, you will just looking at the connector, you will be able to see, okay, this is like SDR 26 or SDR 11, SDR 35. So we integrally cast them into the manhole, and your pipes, any pipe can be seamlessly connected. If we don't have the right connector or already pre-made, we will make the connector out of the FRP. Will fit the pipe. We can make it for RCP, we can make it for fiberglass pipe, for any type of pipe you can think of. or we can use the boot. So this is that with our products for new construction, and I'm going to move over to our rehabilitation solutions, which we see a lot of demand on because, as you know, our infrastructure is aging, and sometimes replacement is not always economical, and so rehabilitation options becomes a more attractive option. So we have solutions for round rehabilitation of round structures. That's your manholes, that's your lift stations, and we also have rehabilitation products for square structures. And these are permanent solution. It's not a lipstick where you know, rehabilitate and then you have to come back in 7 or 10 years to rehabilitate again. So first, I'm going to talk about our rehabilitation of manholes, which all the agencies have manholes, some amount of manholes that need to be rehabilitated. And this is a structural rehabilitation, not just permanent, but also structural rehabilitation. This manhole can support the HS20 load on itself, on its own. So if you have a severely deteriorated manhole, you may want to consider, just instead of digging it out and replacing it, maybe you want to consider rehabilitating instead with this option. So when you rehabilitate with PVC hybrid manhole, you don't need to necessarily to bypass, right? You can do it on a live sewer. We've done several projects which did not require bypass, or you could perform that rehabilitation without bypass. That significantly saves funds on bypassing for the agency and speeds up the rehabilitation. It's relatively simple and fast. We had a project where we rehabilitated 2 manholes in basically 2.5 days. That's including excavating the top lids and cleaning and installing and putting it back into service. We offer a 50-year warranty against corrosion with this solution. Again, this is a very superior warranty that we offer as compared to spray-on liners. Because we are that confident in this solution. So when you think about, you know, if you only have to do it once, yes, it might be more expensive than spray-on solution, but you only have to do it once and don't have to think about, you know, digging it out, do traffic control, cleaning again. So this is once and done solution. And the second one is the FRP panels. These are square panels, corrosion-resistant panels that you mechanically attach to the square structures where you have straight walls. This solution is easily customizable. It's a lightweight. You don't need to remove necessarily the top lids. You can directly feed it either through the hatch or through the opening that you have. They can be cut and customized in the field. So the panels, the solution with panels, we offer 25-year warranty and 100-year design life. So the panels consist of honeycomb core, so which gives the rigidity to these panels, and it's covered with FRP fiber reinforced plastic, that the same material that we use for lining our perfect line manholes and making the bases, lining the bases for it. So these panels provide rigidity, and because of that, once you mechanically attach them to the wall, you can grout behind it. So if you have severe deterioration of the wall, if you have some loss in thickness or concrete, you can use these panels basically as a bracing. So, support system for restoring that thickness of the wall. So typically when you line or when you re-pour the wall, you have to brace it with something like metal or the wood panels. These FRP panels can serve you as that, so you don't need to do additional bracing. So they mechanically bolted to the wall. Now we on the fourth structure, wet well in Arizona, that we using this FRP panels to restore square structures. So once you install it, you seal the seams and then test your structure for water tightness. And next product is PVC hybrid manholes. That's for the round manholes that, as I mentioned. So the idea is without removing of the existing manhole, you can slide the inserts into the manhole, then slide the riser and cover it with a lined lid. So this is a project from Surprise, Arizona. First of all, we can scan the manhole to determine configuration of your manhole. So if you have a odd troughs, we can determine based on the digital model of that manhole. And based on the digital model, we will create a custom fit liner. So for that particular project, we had 2 concrete manholes that needed to be rehabilitated. The time was of the essence. We offered this as a solution that does not need a bypass. So the contractor was able to rehabilitate 2 manholes within 2.5 days. So those 2 manholes were downstream from the active lift station. So once we scanned the structures, we custom made the liners, and then it was delivered to the job site. And again, this liner is made out of FRP. It's corrosion resistant. It's also highly impact resistant as well. So if you, let's say, drop a hammer, it doesn't necessarily gonna chip or break. So this is just a picture of the repair process. If you for any reason have a chip or a crack, the repair process is not very complicated. With a little bit of instructions, the field crews can easily repair. So there's no like welding certification is needed, but with proper instructions, the liners, if they damaged, can be repaired. So at the job site, yeah, typically you can self-perform. If you have several people on your team, they can install the manhole in 1 or 2 days, as long as you have the right size lifting devices. So you've got to prepare a surface. Of course, you don't want any debris going into the sewer, so you do want to have lining at the bottom to capture all the debris. Pressure spraying is not necessary, but you do want to have all the loose material off the walls. Then once you cleaned it, you don't need to do etching or any special preparation. You lower the liner, set it in place, lock it, and then here's a picture of the plug that you put into the troughs. So it's impregnated with the resin, and once it gets into contact with water, it starts hardening. So once you put it on the pig, you expand the pig, it gets into contact with water and starts adhering to your existing pipe. So that's how you make connection between the liner to your existing pipe. So once you have the liner in place, you will grout behind the liner, and then once the base liner is in place, you put the mastic and lower the PVC riser. Once the PVC riser is in place, you want to make sure it's perfectly vertical, and you're going to have this annular space. And one thing I wanted to mention, when you use the solution, you will lose one diameter of the size for your manhole. So for example, if you have a 60-inch diameter manhole, it will become 54. Typically, it's not an issue as long as those are maintenance holes, right? So you just want to make sure the person can fit in there. The problem may arise like if you have equipment there, like for, let's say lift stations, and if you're reducing in one diameter size, you want to make sure your equipment still fits. And if so, that's you will have to determine whether this is the right solution. So once you insert this riser, you're going to have this annular space which you will be grouting. So that's kind of like locks in any room for the oxygen to get in, stops the H2S-based corrosion. And once the riser is in place, then we make these lids specific to fit the risers. They're lined with FRP liner, so they're also corrosion resistant. So once they're installed, you backfill and you put it back into service. So you basically you have a brand new manhole that's gonna last you another, hopefully 100 years if you don't have to dig it out. Possibility to install the ladder again inside. It's not going to be the steps, it's mostly going to be ladder. So you have least amount of penetrations if you really need to. Again, we do not recommend it. And again, we offer 50-year warranty. And I did talk about this FRP panels. This was one of the projects that we did in Bullhead City and in Arizona, where we used FRP panels. So right now we're on the fourth wet well. The owner liked it so much, and they were tired of going back and respraying, because the cost of going respraying, shutting down, bypassing is tremendous. So they decided just to go get it done again once, so they don't have to ever go back again. So with that, I'm gonna finish the presentation, and we're gonna open up for any questions that we have. Brandon, do we have any questions?
There were a few questions in the Q&A that I'll go ahead and read off now. I've provided answers to all of them, I believe. But one of the questions was, what is the maximum pH, or sorry, minimum pH and maximum temperature these liners can withstand? So we generally recommend the FRP liner for wastewater temperatures at or below 160 degrees. The FRP material is the liner that is expected to actually come into contact with wastewater in most applications, either in the base of a manhole or through our FRP panels, which are showed on screen. And so 160 degrees generally. And then as far as minimum pH, that's an excellent question. We've tested these liners with a 20% sulfuric acid solution. That is the actual pH is highly dependent on atmospheric conditions, temperature, things like that. But if somebody would like to get a specific pH reading, we can reach out and provide that for you.
Yeah, it's got to be combination. You've got to be combination where you have increased temperature and let's say lower pH. It's going to be a more severe condition. So we do need to know what's the temperature of the effluent and your pH.
Yeah. The next one, somebody asked, so is the perfect pipe for storm sewer? Because generally concrete pipe is used for storm drain systems. That's an excellent question. Generally, this perfect pipe is used for sanitary sewer collection systems. And the idea is to provide an option that is both structural in that it can handle excessive loading and can be designed for rather extreme loading, as well as if you have something as simple as we don't have much cover over the pipe, but we're going to have high loads, or we're going to have something that's really deep in the ground. We can have a structural solution that also is corrosion resistant through the incorporation of the integrated liners.
Yeah, with that, I wanted to add, nothing precludes you or prevents you from using these pipes for storm drain. Let's say if you have root penetration issues, HDPE liner is highly resistant to root penetration. But also if you have high abrasion condition, HDPE liner on its own has one of the highest abrasion resistance out of all the materials you can use in water and wastewater systems. So my personal opinion, you're probably going to overpay for your storm sewer, but you can definitely use it if you have
Well, and
special
that's not even
conditions.
and that's not even to mention the joint resistance, that if there's even for industrial applications of things where you just need to make sure that that joint is going to perform as best as it possibly can. The perfect pipe works very, very well for that. And then finally, somebody asked, do we have a method for repairing concrete pipe? And unfortunately, at this point, we do not have any rehabilitation products for concrete pipe. But anybody that has specific concerns with their concrete infrastructure, my entire role here at Geneva Pipe is to serve as an industry resource. So I have put my email in the response to that specific question, and I'll also put it in the chat. If anybody has any questions regarding concrete infrastructure, please feel free to reach out. That's literally what I do day in and day out. So,
Mm.
other than that, I did not see any other questions.
Great. One thing I wanted to add, if you wanted, I kind of like we briefly went over all the solutions we offer. If your company or agency wants to hear more about case studies or particular product a little bit more detailed because you're working on the project, feel free to reach out to us. We'll be happy to either come out and do a presentation and maybe even have some samples for you so you can touch and feel how this product look like. Yeah, reach out to us if you have any projects or desire to learn more. Thank you, everybody.
Thank you, everyone.